So here's a nice practical application problem. Look at this. It gives you a parallelogram and it asks you, is this a rectangle? And justify your answer. Well, how are you going to do that? Well, you know that right angles make up a rectangle, right? So here's a rectangle. So that means every corner has got to be a right angle. Just because this guy is somehow twisted to look like that, the idea here then is determine the slopes. If this slope is a negative reciprocal of this slope, they are perpendicular. So let's find out. Okay, so first thing I'm going to do is I want to look at this line here, F to E or EF, and I want to compare it to this line here, which is EH, and see what in fact are the lines doing. Are they negative reciprocals of each other? Well, easy. Do it right off the graph. Don't even bother with the formula. I suppose you could do both, okay? But I'm going to keep this podcast kind of short. I want to be able to just read it right off the graph. So here we go. Starting from F and going to E because I always read left to right, okay? So here's what I'm going to do. Rise. 1, 2, 3, 4, 5. I'm going to rise 5 and run 1, 2. So rise of 5. 1, 2, 3, 4, 5, run of 1, 2. There's the slope. The slope is a rise of 5, run of 2. That's this guy. That's the slope of FE. Now, with that, here's the highlight. I love this. I can actually erase that. Let's now look at this slope here. If it's perpendicular, this guy better be negative 2 over 5, right? So let's try. Starting from E, I'm going to rise of -1. I have my doubts already. And I'm going to run 1, 2, 3. So my rise and run are -1 over 3. There's no way those guys look even close. So no, this is not a rectangle because they don't meet at 90 degrees. That's how you do a question like that. You could use the formulas, but I think just taking this right off the graph makes it so much easier.